talking about L'Hopital's rule. L'Hopital's rule. And if you're correct in the original, there's even a little hat on it. Okay. All right. So this deals with limits. So this is another way. Okay. To solve limits. This is not expressly in the AB calculus curriculum. I don't have to teach this to you. So it's not going to be tested directly, but you can use this method to solve limits on the tests. Okay? So you're not going to be asked about this rule, but you can use it as a method. So I want to give you this tool because it's really straightforward and it's really useful. Okay? So we're going to use it when we have fractional limits, such as what we have on the board over there. Okay.
Makes me sad that we're going back to limits.
You're always going to
I'd
be.
rather do limits than derivatives. I'd rather.
Okay. You have to, here's the condition. Okay, that has to be first. F and G have to be differentiable. Okay. And this is my brain getting ahead of my hand, or my hand getting ahead of my brain. It's a problem when you, never mind. So F and G are differentiable, and this gives you an indeterminate form. Remember those?
Yeah.
Okay, so you have to solve that by plug and chug and get an indeterminate form. Then this is true. You could take the derivative of each of them and resolve it. Okay. So this says if these are differentiable and the original gives an indeterminate form, we can take the derivative of each of them and resolve the problem by plug and chug. This is not a quotient rule. Okay, well, I'll show you an example. So be careful. Not quotient rule. People are tempted to use the quotient rule because it's division, but you don't need to. All right. So that's L'Hopital's rule. Now how do we use it? Right? Let's solve this problem. Okay. The limit. So we have the limit as x approaches 2. X cubed minus 8. X to the 4th plus 2x minus 20.
Is that 2 or just a normal?
2. Okay, plug and chug. What do you get? Yeah. Okay, so now we can use L'Hopital's rule, because that's an indeterminate form, right?
Yeah.
Okay. So You're using derivatives to solve a limit. What's the derivative of the top? And the bottom? Still not used to writing on this thing. You think that would change. Okay, now plug and chug again. Yep, so derivative top and the derivative of the bottom. There's your answer. I would, yeah, you're probably going to have to. Right. But there, you use the derivative to solve a limit. It's very, like I said, if you get an indeterminate form, use L'Hopital's rule. You're good. Okay. I want to show you a few of them to make sure you get it, but. Okay, here's another one.
Oh, of course. Yeah.
Shh, pay attention here. Come on. What's the cosine of power 2? Plug and chug. It's a different problem. What's cosine at power 2? You have to plug and chug these first. 0. Bottom. Are you sure? Yeah, you're right. Okay. It's an indeterminate form, right? Or does it throw you off when I question you?
Yeah, all the time. But then you're like, nah, I'm just kidding. You're right. Okay.
Be sure of your answers. Okay, now, so we can use L'Hopital's rule, right? What's the derivative of cosine squared? Michael, what's the derivative of the top? Don't say that. He cussed. Yeah, he definitely cussed. I'm going to hit him in the head with a 2x4 in shop class later. Continue.
After you write him up on
What is the derivative of cosine squared x?
Having one of those moments where like you really want to.
I call on you because you weren't paying attention.
Hey.
No. So, hey, keep the conversations down, please. This is why we spent a month calculating derivatives, so we can use them. This is a chain rule problem, right? So bring the 2 down, copy the inside to the first power, because it's a power rule, and then times the derivative of the inside. Okay. And then this one is, no, not 1. Think before you write. There's a problem with being a college athlete. You're trained just to do things without thinking, and then you try to stop it, and it doesn't work. Okay, anyways. Cosine x. Okay, so plug and chug again. Cosine at power 2 is 0, right? No.
When you're working the side,
So what does that mean?
Now you
Yeah, do it again.
Kayla, you just cry.
Pretty much. Yeah.
What if it's ridiculous?
Yeah, but solve that without it. Yeah, that's what I thought.
No, I was saying like, wow.
Product rule, yes? So 2, derivative of the first, and then copy the second. Copy first, derivative of second.
So ugly.
Yeah, well. Now if we plug and chug, we're going to get the bottom as 1. Yay, this will be it. What's the top? Sine at pi over 2 is 1, right? And then, so 2. Yeah, we're done. Okay. Otherwise, you're stuck with numerical or graphical inexact methods. Okay.
Wait, I'm confused on why there's 2 negative sign x's.
Because the derivative of the
Oh,
first cosine
And
is negative sign.
then copy it.
Copy the second. Product rule. All right, let me show you one that we can't use L'Hopital's rule, and then we'll be done. Okay. So why does it not work for this one? Some people are very tempted just to take derivatives now. Why can't we use L'Hopital's rule?
But that's not indeterminate.
Yeah.
Okay.
Answer. That's not in indeterminate form.
Any time as long as it's indeterminate.
Right. So be careful there.
So you just have
Okay.
to factor check it.
You have to check it. Because this one's actually easier if you don't use it. All right. And if you do use it, you'll get the wrong answer. Okay. So be careful. Be careful. If you're interested, I know all of you are, there are several more examples in your book. Example 8 is something that pops up now and again. Okay. It's the derivative or the limit as x approaches 0 of x to the power of x, and how we deal with that. So, any questions? Are you happy? I'm going to ask you in 2 minutes, and you're going to say no.
Give me about 2 minutes, I'll be happy.
Okay, there you go. I will pick it up tomorrow. And you have a quiz. Tomorrow's quiz is 4.1 to 4.5. Critical points, points of inflection, increasing, decreasing, concavity, L'Hopital's rule. Mins and maxes, local and absolute. Okay? I'm done.